All right, if you could take out a piece of paper for direct variation and title them direct variation notes, we're going to talk about a few things. So direct variation, in order for you to have an equation that is considered direct variation, the equation has to have a y-intercept and an x-intercept that are both 0. So remember, having an x and y intercept that are both 0 means that they go through the point 0, 0. Just keep in mind that 0, 0 is also called the origin, because that will be important to know when we're talking about graphs and explaining why it is or is not direct variation. Okay, so again, both y-intercept and x-intercept are 0. If we're comparing that to what we talked about last time with slope-intercept form, just a reminder that slope-intercept form was y equals mx plus b, where m was your slope and b was your y-intercept. In this case, for direct variation, that y-intercept is going to be 0. So that means that b is always going to be 0. So really, your equation will be similar to something like y equals mx, because if you add 0, that's just the same thing as mx. When we do have direct variation and we identify it as such, this y equals mx equation becomes something slightly different. And so we will write down that equation. It's y equals kx. This is called the direct variation equation. Okay, with that direct variation equation, k is still the same thing as m. Okay, they're literally the same thing, just like a function is a relation. They mean the same thing. We just give k a new name because it's something specific when we're talking about direct variation. So we need to know k and m are the same thing. The name for k is called the constant of variation. We call it a constant because, again, constant means stays the same, and that number is going to be the same for every ordered pair. So we're going to have what's called a constant of variation, and that's, again, in place of the slope. And then if we were asked to either find this equation or find k, so either we write the equation y equals kx or we find k, we can do that by solving this equation for k, because this is the only missing piece we have to fill in. With y equals mx plus b, we had to find slope and y-intercept, but here we only have to find k to write this direct variation equation. So two ways you can do this. You can either plug in a number for k and x, or sorry, for y and x, and then solve for k, or you can solve this literal equation for k. So think back to quarter one, literal equations. If we were solving for k, we'd have to get rid of the x, and we'd do that by dividing both sides by x. So k's equation would be k equals y divided by x. So you can either, again, use this equation, and again, we got that by solving for k. Okay, or you can just substitute, spell substitute, right? Substitute x and y first, and then solve for k. Either way. Some other things to know is that when we're talking about direct variation, in word form, you're going to see a sentence like this, that y varies directly with x. So the output is first, the input is second. Y varies directly with x just means direct variation. Varies is just another form of variation. Directly is another form of direct. So varies directly means direct variation. And then the last thing, as long as we have an x and a y, so as long as we have one x value and one y value from an ordered pair, we can find that k, just by the way we talked about up here. Okay, so x and y, as long as we have them, we can find them. Okay, this is an example of a real-world problem of why we have something called direct variation. So notice in this real-world problem, when you go to write it down. So first sentence doesn't give us really any information except for that we're saving money. The second sentence gives us some information. We have no money saved right now, so that means after 0 weeks we have no money saved. So our ordered pair for our intercepts, our starting point is 0, 0. Okay, so we have no money saved right now, but we're going to save $50 per week. So we know that we're starting at 0, 0. We have to figure out what represents our x and what represents our y here. So our x variable would be the number of weeks, since we're saving per week, and that's independent. And then our y would be our money saved. Okay, so I can come up with a few ordered pairs just based on that information that I've created. So I can do an XY table really quick, or I could just list ordered pairs. So we already have 0, 0. After 0 weeks, you have no money saved, right? After the first week, you should have $50 saved. Okay, and then using that same logic, after the second week, we'd have 100. After the third week, we'd have 150. Okay, now it says that we want to write the equation to model this situation. Well, we know it's direct variation because it starts at 0, 0, and because I'm multiplying by 50 each time, so I have a constant of variation. If I want to figure out that constant of variation, I either take y equals kx, and I plug in one y value and one k value that's not 0, 0. So I can plug in 50 for y, and then another value for x. I said k, I meant x. So take 50 and take 1, plug them in, and then you can just solve that equation for k. So I know k times 1 is just k, so k equals 50. You could have done that for 2 and 100 or 3 and 150. The other way to do it is you can solve that equation for k first. So k would equal y divided by x, and then you can plug in your y and your x values. So this time we'll plug in 102, and we get k equals 50. Okay, so once we get that constant of variation, because the problem asked for an equation, we just take that constant of variation and we substitute it into the direct variation equation. So remember, direct variation is y equals kx, so it just doesn't have a y-intercept. And then we plug in that number for k, but we leave our x and y variable the same. So this situation represents direct variation. We can find the equation for direct variation, or we can find the constant of variation. If we need the equation, we have to have the constant of variation, though, so that's the only thing we need to know. Alright, so let's look at some examples. So we're going to pause the video right now. Your teacher is going to hand out these examples on a piece of paper for you, and we're going to go through them. Alright, so you should have all of these graphs in front of you. So let's take a look at this first graph right here. So remember, we need to know a few things about direct variation. The first thing that we need to know is that it has to have a y-intercept and an x-intercept of 0. So when I'm looking at a graph, my first check is to see if we have 0, 0 as an ordered pair on that graph. Another way to say that is, does the line go through the origin? So graph number 1, does this line or this graph go through the origin? I hope you said no. We see that it goes through this point right here. So this is not direct variation because the line does not pass through, and you can either list the ordered pair or you could say the origin. It doesn't matter. Okay, that's going to be our check for graphs. Okay, we always have a constant of variation no matter what because that's called our slope. Remember, they're interchangeable. So our check for graphs is always to see if it's going through the origin or not. So taking a look at the second graph, go ahead and ask yourself the question, write down what you think. Okay, does the graph pass through the origin? Hopefully you saw yes here. So that means this is a direct variation equation. Yes, it's direct variation. And then again, because the line passes through, or crosses, or goes through 0, 0, or the origin. Try to avoid words like it or they, so that we know it's the line passing through and not something random. The next graph you see on your paper is this guy right here. So let's take a look at that one. This was number 1, that's number 2, this is number 3. Ask yourself the question, write down if you think it's direct variation or not. And you should have said no. And then again, the explanation would be because the line does not pass through the origin, it goes through the y-intercept of 4. Okay, the next graph that you should see on your paper is this guy right here. Ask yourself the question, write down if it's direct variation or not, and why. Okay, you should have seen that this was not direct variation because the y-intercept was 3, not 0, so it did not pass through the origin. The next graph you see is this guy right here. Okay, you should have written that this is, yes, it is direct variation because it passes through the origin. Last graph you see is this guy right here. Okay, so you should have seen that this one was yes also. The graph does pass through the origin. Notice that on all the ones that are direct variation, it doesn't matter if the slope is positive or negative, or if it's really shallow or really steep. It's still going to be a direct variation equation because it passes through the origin. Okay, let's go ahead and look at how we tell with equations. Okay, so remember, the direct variation equation is y equals kx. So the thing that we're missing is our plus b here, so there is no b when we're talking about equations. I'd like you to go through and identify all the equations that are missing a b value here. Take a minute to do that, pause the video while you're doing it. Alright, so you should have seen that the first equation was yes, the second equation was no, third equation was yes, fourth equation was no, fifth equation was no, and sixth equation was yes. The ones that were yes had no b value, the ones that were no had a b value. I messed up on this one right here, that b is 3. All the other b's are -4. So that's an easy way to check if an equation is direct variation or not. Okay, let's flip to the back and look at how we check for tables. Okay, so 2 checks we need to do for tables. The first check is that we're trying to look for the ordered pair 0, 0. The second check is we need to determine what k is. And we need to determine if there is a k value at all. So, is there k? The easiest thing to do here first is to determine k because I don't see 0, 0 at all. So the way we determine k is we figure out, again, k is equal to y divided by x. So we take our y value, we take our x value, we divide them, and that's going to get us k. So here we have 15 divided by 5. I type it in as a fraction into my calculator. 15 divided by 5 is 3. Same thing for 18 divided by 6, we get 3. 21 divided by 7, we get 3. And 24 divided by 8, we get 3. So we do have a constant of variation. So that equation would look like y equals 3x. Now what we need to do is we need to see if we're going to have the ordered pair 0, 0 following that pattern. So what I like to do is I start with my smallest x value and I go to the next smallest. So 4 was the next smallest. I just extend this table. So to go from 4 to my y value, I multiply by 3. That gets me 12. Do the same thing for 3. That gets us 9. 2, that gets us 6, 1, that gets us 3, and then 0 would get us 0 if we're following that pattern. So this is direct variation, and this is the equation for that direct variation. Okay. We'll look at this next one, same thing. We don't see 0, 0 here, so we want to determine the k value. Again, y over x is what k is equal to. So we're going to do 4 over 16, which gets us 1/4 in our calculator. 16 over 32 gets us 1/2. We can automatically stop there. These values are not the same, so there is no k value here. Because there's no k value, I don't even have to check for 0, 0, because I automatically don't have a k value. So this is not direct variation. All right, let's take a look at the next two. So for the first one, there's an immediate, again, way to check. We always look for 0, 0 first. I do see an x value of 0 right here, but I see that its y value is not 0. Because this ordered pair is not 0, 0, this is not direct variation. I don't even have to check for k. Okay, so that's the first issue, or the first table. The second table, if you could change that last k value to 24, I accidentally left it as 22.5 on the notes, so it's 24. So we're going to do our check. Our first check is, do we see 0, 0? We do here, so that's nice. When I look at 0, 0 and I try to determine k, so the second thing is we need to figure out k. Remember, k is equal to y over x. I don't use 0, 0 for that because 1, I can't divide by 0, and 2, anything times 0 is 0, so that k value could be any number. We will use it for 6 and 4, so we're going to do 6 divided by 4 in our calculator. We should get 3 over 2 if we used a fraction, or 1.5 if we use division. We do the same for 15 and 10. Again, that gets you 3 over 2, or 1.5. Okay, and then do the same thing for 24 over 16. Type that into your calculator. You should see 3 over 2, or 1.5. All right, so with this one, we prove that there's a k, we prove that there's 0, 0, so this is direct variation, and we can write the equation y equals kx using either the fraction or the decimal. So we'll do y equals 3/2 x. If you did y equals 1.5x, that's fine. They are both the equation for direct variation. All right, let's take a look at when we are told that y varies directly with x. Remember, that just means direct variation. We use the specified values. All that means is we have an x value and a y value to write the direct variation equation. Well, remember, direct variation equation is y equals kx. So we need to write that equation, and it needs to relate y to x or x to y. All that means is that you're using that equation. So the very first thing that we need to know is what is k for each of these examples. So let's look at example 1. We've got to figure out what k is first in order to write that equation. So remember, k equals yx. So I plug in my y, which is 6. I plug in my x, which is negative 24. When I do that math in the calculator, I'm going to get negative 1/4. So my k value is negative 1/4. I then take that k value and plug it into my y equals kx equation. I only plug in that k value. I do not plug in my x and my y values because I'm writing the equation. Those x and y we're just using to figure out what k is. So my direct variation equation here is y equals negative 1/4 x. Okay, for number 2, we'll do the same thing. We need to figure out what k is. So k is y over x, so we'll put 8 over 5. That cannot simplify. Check using your calculator, so that will be our k value. We're going to take our direct variation equation, plug in our k value, and we get y equals 8/5 x. All right, go ahead and try it for the second two. Pause the video, and then check your answer. All right, so take a look. You should have gotten y equals negative 4x for the first equation for number 3, and then y equals 1/5 x for the second equation for number 4. Okay, last thing we want to take a look at is just a different way to ask the same question. So again, suppose the y varies directly with x, and y is equal to 36 when x is equal to 2. Write an equation for variation. That just means, again, the direct variation equation. So we're going to want to write a y equals kx equation. We're going to want to figure out what k is. Again, k is y over x. So we're going to substitute in y, which is 36, and x, which is 2. And 36 divided by 2 gets us, what am I thinking of here? 18. You should have typed that into your calculator. It would have simplified to 18. And then we take that k value and we substitute it in for k. So y equals 18x. Go ahead and pause the video and try the next one. Alright, go ahead and check your answers. You should have seen both of those equations. Okay, so this is basically it for direct variation. Next class in our review, we'll look at some real-world examples just to practice, and we'll do some more practice on finding direct variation. Feel free to watch this video again tonight if you need to look back over it while you're doing your homework. I will post it in Google Classroom under the About tab. And then please feel free to come to resource next week or see me in the morning with any questions that you may have.